Hey, welcome to our notes for Unit 8, Lesson 1. And we're going to look today at limits and continuity. We studied continuous functions and different types of discontinuity in the beginning of our pre-calc year. Continuity and discontinuity are coming back now in this lesson as we talk about limits. And limits are usually the first thing that you learn in calculus. So this is just a real quick introduction to limits, and you'll go more in depth with limits when you get to Calc 1 next year. So we're asked on the front here to rewrite this statement in limit notation, and the statement reads, the limit of f as x approaches 3 from the left side is -1. So what is a limit? A limit is a y value coming from one direction or another direction or from both directions. So in this case, we're coming from the left side and we're headed from the left side of our graph towards 3 in the x direction, and the limit is the y direction that would result as we head from the left. We're coming across until we get to x equals 3. And what's the y value doing? So kind of like when we talked about end behavior earlier in the year, as we head toward 3 in the x direction from the left, our y value is decreasing and it's coming down toward y equals -1. And that -1 is the limit. It's the lowest that graph is going to go. Now that does not mean that f of 3 equals -1. We have an open circle on the graph here, so it is not ever going to equal -1. It's undefined where 3 -1 is. That's why there's an open circle. So a limit is not the same as evaluating a function. It's looking where the function is headed. So as we head to 3 from the right, we see the y value is coming down and approaching -1, and that's what a limit is. So the notation for this limit, we would use LIM, and that's usually in lowercase letters, sometimes italics. And underneath that, we put X and then an arrow, and that reads X approaches. And we're approaching the value of 3, and to indicate that we're coming from the left side towards 3, we put a superscript with a minus after the 3. So this is looking for the limit as x approaches 3 from the left. If we wanted to approach from the right side, instead we would put a plus as the superscript. Okay, then the function comes next. So we want to identify this limit as x approaches 3 from the left on the graph of the function of f of x. And when we looked at the graph, we saw that that limit, that lower value that it's approaching, is -1. So that would be our notation for the statement, the limit of f as x approaches 3 from the left side is -1. Now, if we wanted to look for the limit as x approaches 3 from the right side, we would put our plus as the superscript, and that's of f of x. So as we come now from the right side towards 3, our y value is decreasing until it reaches +2. Okay, so the limit from the left, that's this one, is -1. The limit on that 3 from the right is 2. Those don't equal each other. So we would conclude then that the limit as x approaches 3 of the function f of x does not exist. The limit doesn't exist because they don't reach the same value. Now, to look at a graph where the limit does exist, let's go ahead and change the thickness of this line here. So I'm going to just get rid of that part of the function, and let's say instead my function continued like this. So it was a parabola with a hole down here at 3, -1. Now in that case, when I go to find my limits, the limit as I go to 3 from the left is still down here at -1. Now the limit as I approach 3 from the right is also -1. And because the one-sided limits both go to the same value, the limit of x approaching 3 from any direction is -1. Okay, so that's what is summarized for us up at the top here in example 1 in the notes. A one-sided limit is the y value that a function approaches from either the left side or from the right side of a given x value. Right? It's coming from one direction or the other direction, not both directions. That's a one-sided limit. Okay, a limit in general is the y value that a function approaches at a given x value if both the left-sided limit and the right-sided limits are equal, right? They have to be coming to the same value, then you have a limit with no side restrictions on it. So here we're asked to give the value of each statement, and if the value does not exist, if it's undefined, we're going to write DNE does not exist. So in problem A, we're asked to approach 1 from the left, and so this is our graph of f of x. I'm starting here at the left and I'm headed toward +1. So my curve comes down along this rational function. We hop over this vertical asymptote. Now we're coming down along something that looks like a quadratic, like a piece of a parabola. And as I get closer to that value where x equals 1, I see that I end up here at an open circle where y is 3. So that is my limit approaching from the left. Now to approach from the right, the same value of x at 1. Now I'm coming from the right along this constant function, and when I get to 1, right, my piece of the graph that I'm traveling along, it's going to terminate at y equals 2. So my limit as I approach from the right is going to be 2. Now the left-sided limit and the right-sided limit, they do not equal each other. So the limit as x approaches 1, overall limit, right, not coming from the left or the right, but from both directions, that limit does not exist because they're not coming together at the same value. Now, limits are not the same as evaluating a function, right? This function is defined at f of 1. If I substitute in 1 for my x, I get a closed circle at -2. So f of 1 is equal to -2 on this graph. That has nothing to do with the limit approaching from either direction or from both directions. Okay, let's try this second column. We want to find the limit of f of x as x approaches -1 from the left. So I'm starting over here at the left. I come along that rational function, hop over the asymptote, and now here I come approaching -1 in the x direction, and I end up at this open circle at y equals +3. So the limit is going to be +3 coming from the left toward -1. Now coming from the right side, I come along this constant function, right? I have the quadratic function now I can travel along, and I'm approaching -1 along that piece of a quadratic function. Again, I reach this open circle where y is 3, and so that's my right-sided limit. Because my left and right-sided limits are 3, I'm coming together at this open circle, the same y value, and so the limit as x approaches -1 is 3. That limit does exist, and it exists at 3. That's not the same as evaluating the function f of -1. If I put in -1 here for my x on the graph, my y value of 3 is an open circle there at 1 comma, or -1 comma 3, that's undefined. So this does not exist. There is no value when I substitute -1 for x in my function f of x, which is graphed here. Okay, let's try the third column. So I want to find the left-sided limit for -2. So here's -2 on my x-axis. It's a vertical asymptote. As I come from the left, I'm coming along that piece of a rational function, and it's going to go closer, 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 but never is it going to touch or cross that vertical asymptote at -2. So the limit does not exist. However, sometimes it's useful to know that it's not absent because of a hole in the graph or a gap or a jump, but it's headed in a direction, right? It's getting closer and closer and closer, but it's always headed down to -infinity. So you'll often see people write that the limit as x approaches -2 from the left is equal to -infinity, right? That doesn't mean that the limit exists at -infinity, because how are you going to ever reach -infinity, right? You can't. But it's a direction of movement that is suggesting the behavior of the graph that could be useful to us. So it's fine to write that the limit as x approaches -2 from the left is -infinity. Okay, then as we come at this asymptote from the right side, we're coming along this quadratic here, and it looks like right about here it changes from a parabola into the other side of the rational function. So we're going to keep going forever towards but never crossing that vertical asymptote. So again, the limit from the right side, it does not exist, but it would be useful to say that it's headed toward positive infinity on that side. Okay, the limit for x approaching -2 from the right and the left, they're headed to two different directions. So this limit does not exist, right? But it would be fine to say that this is headed to positive and negative infinity, just to clue you into what's happening on the graph. And f of -2 obviously is undefined because that is the location of the vertical asymptote, and nothing can touch or cross that asymptote.